Welcome to our second class of thermodynamics. In our last class, we discussed about what is thermodynamics and some terminologies regarding thermodynamics, and where we have classified the system into broad two categories: homogeneous system, heterogeneous system, and later, depending upon the boundary, isolated system, closed system, and open system. Finally, we discussed a little about what is adiabatic system. And you can see that in the adiabatic system, the definition says that the adiabatic system is one where no thermal energy passes into or out of the system. That means in adiabatic process, no heat enters or leaves a system during the expansion or compression of the fluid composing the system. For example, adiabatic process occurs in the vertical flow of air in the atmosphere. In the atmosphere, the air expands and cools as it rises and contracts and grows warmer as it descends. So it is an example of adiabatic process. Another example is when an interstellar gas cloud expands or contracts. During both of these two cases, when the expansion or compression occurs, there is no transfer of heat into or out of the system. In most of the situations, truly adiabatic changes must take place in short time intervals so that the heat content of the system remains unchanged, or else the system must be perfectly insulated. That means which is practically impossible. That is why we say that adiabatic changes are usually accompanied by changes in temperature. So that's was all about adiabatic system, adiabatic process. Now we are going to discuss about the properties. In a general sense, we know that properties indicates, in case of a human being, if we talk about the properties, then we generally consider his land, his wealth, his money, etc., etc. So what will be the properties in thermodynamics? In thermodynamics, any characteristics of a system in which its physical properties are described is called property. So we can say that the characteristics which can be used to describe the condition or state of a system is thermodynamic property. Let me repeat this again. In thermodynamics, the characteristics which can be used to describe the condition or state of a system is called thermodynamic properties. For example, temperature, pressure, volume, energy, etc. Within thermodynamics, a physical property is any property that is measurable and whose value describes a state of the physical system. Therefore, properties is defined as the characteristic feature of a system by which it can be specified. So basically, we are dealing with the measurable and non-measurable features of thermodynamic system, which is encompassingly known as properties. Now let's move on the type of properties. The properties are basically classified into two categories. Number one, intensive properties. Number two, extensive properties. Number one, intensive property. What is intensive property? Intensive property is a property which doesn't depend on the quantity of matter present in the system. So Intensive property is that property which doesn't depend on the quantity of matter, that means mass of the matter present in the system. For example, the temperature, the pressure, density, and concentration. And you know that this, the name of which I have already mentioned, that these properties do not depend upon the quantity of matter. For example, if the overall temperature of a glass of water is 20 degrees Celsius, then any drop of water in the glass must have 20 degrees Celsius temperature. That is why temperature is intensive property, because it doesn't depend upon the quantity of matter. If we mix a glass of water, suppose we have two glasses of water, one is 30 degrees Celsius, another is also 30 degrees Celsius. If we mix these two glasses of water, then the temperature will not rise to 60 degrees Celsius. It shall remain 30 degrees Celsius. That is why it is intensive property, because it is not depending upon the quantity of the matter. Similarly, if we have 100 ml, 100 degrees Celsius temperature, a glass of water, we have 100 ml water, which is in the 100 degrees Celsius temperature. If we divide this 100 ml water into two portions, then there will be each portion, that means 50 ml of water, and another is 50 ml of water. This first 50 ml of water will have 100 degrees Celsius temperature. Similarly, the second portion of water, which is 50 ml water, and which also have 100 degrees Celsius temperature. That is why it is intensive properties. It is not depending on the quantity or amount of the water. So temperature is intensive properties. In the similar manner, pressure is also intensive properties. It doesn't depend upon the quantity of the matter. Suppose you have 5 kg cotton and you have 5 kg iron, the standard iron, which is 5 kg, and you have also 5 kg cotton. Although the volume, although the amount, the mass of the cotton and mass of the iron is same, but the pressure of the iron is much more greater than the pressure of the cotton, because the surface area of the cotton is large, but the surface area of the iron is not as much large as the cotton. If you are a human body, human being, you are a human being, you are a man or a woman, whatever you are. If you lie on the bed, then the pressure exerted on the bed is low. Instead, if you stand on the bed, then the pressure exerted on the bed becomes very much greater than that of when you are lying on the bed. Although you are the same man, your temperature, your body mass is the same. Suppose you have 50 kg body mass, and whenever you are lying on the bed, you are exerting less amount of pressure on the bed. And the same person, you have 50 kg weight, and whenever you are standing on the bed, you are exerting much more greater pressure than when you are lying. That means the pressure is not dependent upon the mass. It depends upon the force per unit area. So it is an intensive properties. In a similar manner, density is also an intensive properties. If you prepare 1 liter 0.1 normal sodium hydroxide solution, and if you take out only 100 ml of sodium hydroxide solution, then the concentration of the 100 ml sodium hydroxide solution will be same as the 1 liter of sodium hydroxide solution. That means 0.1 normal sodium hydroxide solution. Even 1 drop of sodium hydroxide solution will have the same concentration. That means 0.1 normal sodium hydroxide solution. So the concentration is not dependent on the amount of matter. That is why it is an intensive properties. And in the similar manner, the density also do not depends upon the amount of matter. In my previous example, I told you that whenever you pick up 5 kg of iron and 5 kg of cotton, the volume of the cotton is much more greater. But the volume of the iron is very much smaller. And there is a different relationship or inverse relationship between the volume and the density. That is why the density of the iron is much more greater than the density of the cotton. Although the mass of the cotton and the iron is already same, but the density of the cotton and the iron is totally different. So these are the intensive properties which do not depend upon the mass or quantity of the matter present in the system. Okay, let me recapitulate the main points again. Intensive properties are those properties which do not depend upon the quantity of the matter present in the system. The first example was temperature, which do not depend upon the quantity of matter. If the temperature is depends on the quantity of the matter, then if you mix 30 degrees Celsius water with 60 degrees Celsius water, then the 30 degrees Celsius and 60 degrees Celsius water should become a 90 degrees Celsius temperature water. But in practical, it do not happen. Also, if you divide a 100 degrees Celsius temperature water into 2 portions, the individual portion should become a 50 degrees Celsius temperature water. But in practical, the temperature remains same. So the temperature do not depend upon the mass. The second example was pressure. I told that if a person with 50 kg weight lie on the bed, he or she will exert less pressure. Instead, if the person stand on the bed, he or she will exert much more pressure. In the both cases, that means when the person is lying and when the person is standing, the temperature, the mass, that means the weight, remains the same. So the pressure is not dependent on the weight, but it basically depends upon the angle and the area, force per unit area. So it is an intensive properties. The third example was density, and in that case we talked about a 5 kg iron and 5 kg cotton. Although the weight is same, but the density of iron is much greater than the density of cotton. And finally, we talked about concentration. In that case, we made 1 liter 0.1 nanomole sodium hydroxide solution. And if we take 1 drop of 0.1 nanomole sodium hydroxide solution, the 1 drop will also have 0.1 nanomole sodium hydroxide solution. If we take 100 ml, the concentration will remain the same. If we take 50 ml, the concentration remain the same. So all these are the example of intensive property. Now come to the extensive property. What is extensive property? It is totally different from the intensive property. And it says that the extensive property is the property that does depend on the quantity of the matter present in the system. So extensive property depends on the quantity of matter present in the system. For example, the volume, number of moles, enthalpy, entropy, Gibbs free energy, etc. are the extensive properties. Since it depends upon the quantity of matter, so as the quantity of matter increases, the value of this property also increases. For example, if we have one of the property is volume. Volume is an extensive properties. So if we add 50 ml water with another 50 ml water, then the total volume becomes 100 ml. In the same way, if we add 3 mole with 2 mole, 3 mole and 2 mole becomes 5 mole. In the same manner, the enthalpy, entropy, and Gibbs energy also increases whenever new volume of entropy, enthalpy, and Gibbs energy is added. Since addition of similar thing increases the property, and if we reduce the volume, if we have 100 ml of water, and if we take out 50 ml water from the 100 ml water, then it will reduce its volume. So since addition of the amount of matter increases the property, that is why extensive property is also known as additive properties. Extensive properties also known as additive properties. That means if we add the similar thing, the property will increase. Like if we add 50 ml water with another 50 ml water, it will increase into 100 ml water. If we add 3 mole with 2 mole, it will become 5 mole. That is why it is known as extensive properties, and it is also known as additive properties. So if we summarize and contrasts with the intensive property, the extensive property, we can say that intensive property do not depend upon the matter. Extensive property depends upon the quantity of matter present in the system. Intensive property is non-additive property, while the extensive property is additive properties. Okay, now let's move on our next topics. State. First of all, what is thermodynamic state? We have to know what is state. Basically, state means condition. State means condition. If we say what is the state of this person, you can say that he is standing, or he is lying, or he is just sitting. It is the state of that person. If we talk about the state of a country, we can say that it is in miserable condition, it is in healthy condition, it is another state. So state, the term state has different meaning and different sector. So in case of thermodynamics, what will be the actual meaning of state? In thermodynamics, when all the properties of a system, when all the properties of a system becomes fixed, then the condition of that system is known as thermodynamic state. Let me repeat this again. When all the properties of a thermodynamic system becomes fixed, then the condition, then after fixing all the properties of a thermodynamic system, we will get a condition. Then this condition of that system will be regarded as the state of the system. This condition of that thermodynamic system will be regarded as the state of thermodynamic system. So how did we say? We said that when all the properties of a thermodynamic system becomes fixed, then the condition of the thermodynamic system is known as state of a system. And what are the properties that must be fixed to know that must be fixed to make a thermodynamic system into a particular state? The properties that must be fixed are pressure, temperature, volume, and mass and composition. These 5 things: pressure, temperature, volume, mass, and composition. When the temperature, pressure, volume, mass, and composition all are fixed, then the condition of the thermodynamic system will be regarded as the state of system, will be regarded as the state of that thermodynamic system. Since a change in the magnitude of such properties alters the state of the system, these are referred to as state variables or state functions or thermodynamic parameters. It also stands to reason that a change of system from initial state to the final state will be accompanied by change in the state variables. And we can constitute or construct some equation like P is equal to nRT. And if you construct or constitute such type of equation, this equation will be regarded as equation of state. In case of a equation of ideal gas, P is equal to net T, if we fix the P, if we fix the T, then since R is already constant, then we can easily find out the volume of V. PV is equal to net T. If we fix the P, if we fix the T, R is already constant, then we can easily find out the third parameter V. Whenever this type of fixing occurs, then the P and T will be regarded as independent variables. That means independent state variables. And the remaining state variable, that means the V or volume, which depends on the value of P and T, will be regarded as dependent state variables. Will be dependent state variables. Okay, now let's move on the classification of state of a system. Hope we have understood what is state, and now let us talk about what are the types of state. In thermodynamics, there are basically two types of state. One is equilibrium state, and another is non-equilibrium state. What is equilibrium state? A system in which the state variables have when the state variables have constant value throughout the system, then it is said to be in a state of thermodynamic equilibrium. When all the state variables have constant values throughout the system, then it is said to be in a state of thermodynamic equilibrium. Suppose we have a gas confined in a cylinder that has a frictionless piston. If the piston is stationary, then the state of the gas can be specified by giving the values of pressure and volume. The system is then in a state of equilibrium. Now, what is non-equilibrium state? A system in which the state variables have different values in different parts of the system is said to be in a non-equilibrium state. That means the state variables are not fixed throughout the system. That is why it is non-equilibrium system. For example, if the gas contained in a cylinder, as stated above, in case of equilibrium system, is compressed very rapidly by moving down the piston, then it passes through the state in which the pressure and temperature cannot be specified. Since these properties vary throughout the gas, that is why it is called a non-equilibrium state. And in that case, the gas near the piston is compressed and heated, and the gas at far end of the cylinder is not heated and not compressed. That is why it is in the non-equilibrium state. Hope you have understood what is state, and if now let us recapitulate the main points again. When all the state variables are fixed, then the condition of the thermodynamic system is known as state of system. Then the question arises, which compositions or parameters must be fixed to know the state of the system? There are 5 parameters that must be fixed for knowing the state of the system. They are pressure, volume, temperature, mass, and composition. Since these parameters must be specified for specifying the state of a system, these are known as state variables or state function or thermodynamic parameters. And if we construct an equation, for example, P is equal to T, where all the parameters already present, then this type of equation is known as equation of state. And from this equation, we can find out any particular volume of either temperature or pressure or volume. For example, in case of P is equal to T, if you know the pressure, if you know the temperature, and R is already fixed, then we can find out the value of V. So since the value of V depends on the value of P, value of T, that is why value of V is known as dependent variable and P and T is known as independent variable. Next comes the types of state. Basically, there are 2 types of state. One was equilibrium state, another was non-equilibrium state. In case of equilibrium state, all the state variable had constant value throughout the system. And in case of non-equilibrium state, all the state variable did not have any constant value throughout the system. Rather, it had different values in different part of the system. So that's all about the state of the thermodynamic state of the system. Now, let's move on. Thermodynamic process. Thermodynamic process. What is thermodynamic process? Whenever a thermodynamic system changes from one state into another state, then this operation, that means this changing, is known as the process. Whenever any thermodynamic system changes from one state to another state, then this operation is known as thermodynamic process. And you can easily understand that whenever a state, thermodynamic state changes, then the state variable must be changed. That means the temperature, pressure, volume, mass, and composition must be changed. Through changing this temperature, pressure, composition, mass, one state transforms from the previous condition into the former condition to the present condition. And this changing is known as the process. And this changing is demonstrated by the indicator diagram, where the x-axis contains the volume and the y-axis contains the pressure. And this type of diagram is also known as PV diagram. This is indicator diagram, also known as PV diagram. Now, there are basically 5 types of thermodynamic process that can take place whenever one state is converted into another state. And these processes are isothermal process, adiabatic process, isobaric process, isochoric process, and cyclic process. Iso means same, and you know that thermal means heat energy. Isothermal means there is no change in temperature. Isobaric means there is no change in pressure. Isobaric means there is no change in pressure. Isochoric means there is no change in volume. There is no change in volume. Adiabatic means there is no exchange of thermal energy. There is no exchange of, there is no change in thermal energy. Isothermal means same temperature, the temperature will not change. Adiabatic means there will be no exchange of temperature. There will be no exchange of temperature into or out of the system. Isobaric means there will be the pressure will be, there will be no change in the pressure. Isobaric means there will be no change in the pressure. Isochoric means there will be no change in volume. Isochoric means there will be no change in volume. And cyclic process means there will be a cyclic process. That means there will be a cycle that will initiate from the 0 point and will continue to go on and will repeat again and again. Okay. Now let me say again, isothermal means there will be no change in temperature. Although the temperature may come or may go into or out of the system, but the temperature will remain the same. For example, if you boil the water is boiling and it is getting heat from the flame, and the heat is evaporating and surrounding and spreading throughout the environment with the help of vapor. So the heat is spreading. That means it is gaining heat. It is at the same time it is also losing the heat. But the temperature of the water remains constant. It remains 100 degrees Celsius. Although it is gaining heat from the flame, and it is losing heat through the movement of the vapor. That is why it is isothermal process. In the same manner, in isobaric process, it may acquire pressure, it may lose pressure, but ultimately there will be no change in pressure. Just like our body may acquire heat, body may lose heat, but ultimately our body temperature remains 98.4 degree Fahrenheit. That means our body operates in isothermal process. Gaining heat is possible, losing heat also possible, but the temperature remains same. That is why it is isothermal process. Gaining pressure is possible, losing pressure is possible, but the pressure should remain constant throughout the process. That is why it is known as isobaric process. In the similar manner, in isochoric process, it may acquire volume, it may lose volume, but the ultimate volume always remain the same. It may be gaining something, increasing its volume. At the same time, it may be losing something. So the amount it is gaining is also losing. That is why its volume is not changing. So it is known as isochoric process. For example, let me say that in case of a water tank, suppose you are pouring water into your water tank. At the same time, you are losing water through your tap. So water is pouring through the pump into the tank, and at the same time it is losing its water through the tap, but ultimately there is no change in the volume of the water in the tank because it is losing and gaining at the same time. That is why it will be regarded as isochoric process. There is no change in the volume of the water. In case of isobaric process, the same thing will happen. The pressure will remain unchanged, although it may gain pressure or it may lose pressure, but the pressure remains unchanged. But in case of adiabatic process, there will be no exchange of heat into or out of the system. It is a different types of process. Now let's move on individual process. First of all, it is the isothermal process. I've already told you that isothermal process is that process where the temperature remains fixed or constant. The temperature remains fixed or constant. That is why it is isothermal process. A question is that the x-axis contains the volume and the y-axis contains the pressure. So how does this isothermal curve can be drawn within this graph? Because there is nothing relating the temperature. X-axis deals with the volume, y-axis deals with pressure. Then how does this isothermal curve appears in this graph? Basically, whenever the temperature remains fixed, then there is a inverse relationship between the pressure and the volume. You know that according to the Boyle's law, at fixed temperature, the volume of a fixed mass of gas is inversely proportional to its pressure. That means whenever the pressure increases, the volume decreases. Whenever the pressure decreases, the volume increases. So this graph is representing the pressure and volume when the temperature is fixed or temperature do not change or temperature remains fixed or constant. I think you have understood this term. Let me repeat this again. This x-axis deals with volume, this y-axis deals with pressure. So there is nothing about the temperature. Then how does this isothermal curve appears in this graph? The answer is basically at fixed temperature, the volume of a fixed mass of a gas is inversely proportional to its pressure, and it is the Boyle's law. In that sense, this graph represents the relationship between the pressure and the volume when the temperature remains fixed or constant. That is why this curve is appearing in this graph. Okay, and example of isothermal process is constant temperature bath. I have already told you that. Suppose you are heating the water and the water is losing its temperature. Although it is gaining temperature and losing temperature, but its temperature remains 100 degrees Celsius during the entire period of time. So it is isothermal process. The next is adiabatic process. In case of adiabatic process, there is no flow of heat into or out of the system. That means there is no flow of heat out of the system. In case of isothermal system, the heat may flow into or out of the system, but the temperature should remain constant. But in case of adiabatic process, the temperature already remains constant and there is the flow of heat is totally prohibited in case of adiabatic process. That is why the adiabatic curve is steeper than the isothermal curve. The adiabatic curve is steeper than the adiabatic curve, and it also represents the relationship between the pressure and volume when there is no change or exchange of heat into or out of the system. And the example of thermoadiabatic process is thermos flask or thermos bottle. And the third one is isobaric process. Next comes the cyclic process. So what is the isobaric process? The isobaric process is those process which takes place at constant pressure and there is no change of pressure during the transformation from one state to another state. For example, heating of water to its boiling point and its evaporation take place at the same atmospheric pressure. These changes are therefore designated as isobaric process and are said to take place isobarically. Okay. So what was isobaric process? The process which takes place at constant pressure and there is no change in pressure during the change of one thermodynamic state to another thermodynamic state. And the example was heating of water to its boiling point and at the same time its vaporization which took place at the same atmospheric pressure. So the water is heating and the water is evaporating and everything is occurring in the same atmospheric pressure. Maybe that may be 25 degrees Celsius and 1 atmospheric pressure. Since the atmospheric pressure do not changes, then this is known as isobaric process. And our fourth process is isochoric process. As the name suggests that the isochoric process are those processes in which the volume remains constant. That means there is no change in volume during the transformation of one thermodynamic state into another thermodynamic state. And the example of isochoric process is the heating of a substance in a non-expanding chamber is the isochoric process. For example, if we if you are cooking with the help of a pressure cooker, then what happens? The pressure cooker, inside the pressure cooker, the temperature, whenever the temperature increases, the boiling point of the water also increases, and much more higher temperature is required for making the water to boil inside the pressure cooker. And the pressure inside the cooker also increases. But the volume of the cooker do not increases. The volume of the pressure cooker remains same. But in case of balloon, if we pour some lighter gas like helium or neon inside the balloon, then what happens? Then this balloon increases in volume. As the pressure increases, the volume also increases. But in case of pressure cooker, the pressure inside the cooker increases during the cooking, but the volume of the pressure cooker remains constant. since the volume do not changes, that is why it is known as isochronic process. Now the final one, cyclic process. And you can see that in this graph, this line represents isobaric process. That means there is no change in volume. This line represents isochoric process. That means there is no change in pressure. And this line represents adiabatic process. That means there is no movement of heat into or out of the system. Now, you can see that the process may start from this point, move forward, then it can move downward, and then it can move upward. Or you can see that it may start from this point, move backward, then it can stop here and move downward because this is a adiabatic process, and it can move upward in the isochoric process. If this cycle remains happening one after another, that means one cycle, then another cycle, then another cycle, then another cycle. Whenever this type of cycling of the process occurs to be continued, then we will say this type of process as the cyclic process. So what can we say? We can say that when a system in a given state goes through a number of different processes and finally returns to its initial state, the overall process is called a cyclic or cycle process. That means whenever the system of thermodynamic state goes through a number of different processes like isochoric process, isobaric process, and adiabatic process, and finally returns to its initial state. That means it was started from this point and ultimately returns to this point, moves through this line, moves through this line adiabatically, and moves through this line isochorically, and finally returns to this initial point. If such incident happens, then we will say that this is a cyclic process. This is a cyclic process. Okay, now let me show you the symbol of representing the process. In case of isothermal process, the change in temperature, D means small change in temperature, delta T is 0, there is no change in temperature. Adiabatic process, dQ is 0, D means small change, and Q indicates the heat, amount of heat. So there is no change in heat, that is why dQ is equal to 0. In case of isobaric process, dP is equal to 0, D means small change, and P means pressure. There is no change, even there is no small change in pressure, that is why dP is 0, that means delta P is 0. In case of isochoric process, there is no change in volume, that is why del V dV is 0. Delta is the capital letter and D is the small letter. dV indicates delta V. Basically, there is no change in volume, that is why it is isochoric process. And in case of cyclic process, dE, there is no change in energy, dH, there is no change in heat or enthalpy, that is why in cyclic process D is equal to 0, dH is equal to 0. Hope you have understood today's discussion, and we discussed about thermodynamic process. Before that, we discussed about the thermodynamic state and types of state. And at the beginning, we discussed about what is thermodynamic properties and types of thermodynamic properties, basic differences between the thermodynamic properties. And that's all for today. And in the next class, we shall be discussing about another types of processes known as a reversible process and irreversible process. Thanks to all for listening and participating in our class. Have a nice day.